Physicists from around the world were incredibly excited to see the greatest, most advanced high-energy particle collider become operational. After all, they had patiently waited for decades to finally watch this amazing invention revolutionize our knowledge and understanding of the universe. The big machine, called the Large Hadron Collider, was made by a group called CERN. It started working in September 2008 after taking a really long time to build. The people who made it needed a few more years to make it perfect. Since then, the Large Hadron Collider has helped scientists learn a lot about the universe. But recently, the scientists found something surprising and worrying when they used the machine with more energy. They're still trying to figure out what caused it, but they only have theories for now. CERN, with the help of over 10,000 scientists from many countries, built the biggest and most powerful particle collider from 1998 to 2008. It's a 27-kilometer tunnel under the border of France and Switzerland. The first time particles collided with this collider was in 2010, and it had a lot of energy. After some upgrades, it could go even faster. The collider has 4 places where particles collide, and there are 7 detectors to see different things happening. The main thing it does is make proton beams crash into each other, but it can also make heavy ions go fast. Every year, they do special collisions for a month. The reason for this big machine is for scientists to test their ideas about particles. They're especially looking at something called the Higgs boson and trying to find new particles that some theories predict. Hadrons are tiny particles inside atoms, made up of even smaller parts called quarks. They stick together because of a strong force, kind of like how atoms stick together because of a force called electromagnetism. Some common hadrons are protons and neutrons, known as baryons, and other ones like pions and kaons. A collider is a machine that speeds up small particles and smashes them into each other. These machines are super tricky to build, but in science, they're like super-powered magnifying glasses. They help scientists see things at a really tiny level. Colliders make particles crash together really hard, and when that happens, they break into smaller bits for a super short time. These tiny bits are crucial to study, but they disappear so quickly that colliders are the only way to see them. The collider is in a round tunnel underground, varying from 50 to 175 meters deep. They put it underground so it's easier to build and so it doesn't mess up the land above. It's also better because the ground above the tunnel blocks some unwanted rays. The tunnel goes through France and Switzerland, but most of it is in France. The building above it has important machines to control everything. The collider at CERN is a huge deal for science. It makes tons of data, like 15 petabytes each year, and helps scientists understand the smallest things in our universe. It's a bit like a big microscope that smashes particles to help us learn more about how everything is put together. The computer network built for the Large Hadron Collider, LHC, was set up to manage the huge amount of information gathered from its experiments. It's a big project that links computers across the world. Building the LHC itself was super expensive, costing about 7.5 billion euros. It's one of the priciest scientific tools ever made. The plan to build it got the thumbs up in 1995 with a budget of 2.6 billion, plus another 210 million for experiments. When the LHC started running in September 2008, it hit a snag. A magnet problem delayed tests for 14 months. Super expensive, costing about 7.5 billion euros. It's one of the priciest scientific tools ever made. The plan to build it got the thumbs up in 1995 with a budget of 2.6 billion, plus another 210 million for experiments. When the LHC started running in September 2008, it hit a snag. A magnet problem delayed tests for 14 months and messed up over 50 super strong magnets and the pipe they go through. During its first big run from 2000, piece of physics that people thought existed but hadn't seen because it's really tricky to find. Scientists at CERN guessed that if their ideas were right, the LHC would make lots of Higgs bosons every minute. This would prove if the Higgs boson was real or not. Besides that, the LHC also helped scientists look for other new particles that were just theories. In 2008, the Large Hadron Collider, LHC, started its tests. It worked from 2009 to 2013, then had a break for upgrades until 2015. Next, it ran from 2015 to 2018 before another shutdown until 2022. In April 2022, the LHC restarted with more powerful beams. This new phase is expected to continue until 2026. During this time, on July 7th, something strange happened. There was a crack in the Earth's magnetic field, and it wasn't a quick thing. It stayed open for 14 hours. This lets strong solar winds come in and create amazing auroras. People who love sci-fi got excited and even had fun ideas, like a villain from a show coming through the crack. But that's just a dream. The aurora caused by this crack, though, was so stunning that it caught everyone's attention. So, what caused this crack? It happened because of something rare called a co-rotating interaction region, CIR, from the Sun. These are big plasma structures made when fast and slow solar winds mix in the heliosphere around the Sun. This heliosphere includes the Sun's magnetic field and the winds it sends out. These CIRs, like coronal mass ejections, CMEs, shoot out from the Sun towards Earth. They can carry shock waves and strong magnetic fields that make space weather stormy. Usually, this shows up to us as beautiful auroras. This time, the CIR hit Earth's magnetic field on July 7th and caused a long-lasting storm. Scientists say that before the CIR, there was a coronal mass ejection in the solar wind. This all led to a G1-class geomagnetic storm. That's what made the crack in the Earth's magnetic field and caused those amazing auroras on July 7th. So what about this crack in the Earth's magnetic field? Well, experts say there's no need to worry. Earth's magnetic field is like a protective shield against solar storms from the Sun. It's normal for the field to have cracks, and usually they come and go quickly. However, recent cracks have surprised scientists by staying open for several hours. Harold Freyer, who led a study in 2003, explained it like having a window stuck open during a storm in your house. While the house mostly blocks the storm, some wind and rain still get through. Similarly, our magnetic shield stops most space storms, but some energy can slip through the cracks. This can sometimes cause issues with things like satellites, radios, and power systems. Luckily, when this crack appeared, there were no radio blackouts or power outages. Instead, people in Canada and the US got to enjoy spectacular northern lights. Scientists also shared that the Sun is becoming more active in its solar cycle, earlier than expected. This means the chances of seeing auroras, like the northern lights, are good and will get even better over the next 3 years. The discovery of the crack in Earth's magnetic field isn't the only interesting thing happening. The Large Hadron Collider, a big scientific machine, found other discoveries too. In 2017, they shared findings from the data collected in 2016. They studied the Higgs boson, a tiny particle, in more detail and improved the accuracy of other results. Since March 2021, the collider has found about 59 new particles in the data from its first 2 runs. On July 5, 2022, scientists found a new kind of pentaquark, a particle made of specific types of smaller particles. They update the machines they use, making them better at creating collisions and detecting particles, possibly increasing collision energy to 14 tera electron volts. They began making a more powerful Large Hadron Collider, called the High Luminosity Large Hadron Collider, in June 2018. This upgrade is meant to start giving us more new discoveries around 2027. It aims to make the machine brighter, which helps to see rare events more clearly and get more precise measurements. The first time they used the collider, they found the Higgs boson, a big deal in physics. The second time, they learned more about how the Higgs boson breaks down. This confirmed that the Higgs boson gives mass to heavier particles. This third phase is seen as a step towards making the Large Hadron Collider better, that should double the amount of data they have. After this third phase ends around 2025, they'll spend a while getting ready for more experiments, until about 2029. Then, they'll start the fourth phase, which will have more collisions and gather about 10 times more data than the third phase, until 2042. Getting the most data the Large Hadron Collider can collect. At the heart of LHC physics lies the study of what happens when protons collide. Protons, though not basic particles themselves, are a mix of smaller bits called quarks and gluons, held together by strong nuclear force. When 2 protons crash, they burst apart, spilling out these particles. Most times they reform into familiar particles like protons or pions. But occasionally, just a few quarks or gluons smash together, concentrating their energy into a tiny area, releasing it as they separate. In the LHC, 40 million proton bunches collide every second, each with at least 50 individual collisions. There might be only a handful of specific events involving crash. They burst apart, spilling out these particles. Most times they reform into familiar particles like protons or pions. But occasionally, just a few quarks or gluons smash together, concentrating their energy into a tiny area, releasing it as they separate. Studying these rare reactions lets physicists peek into nature's rules at incredibly tiny scales. The LHC keeps collecting data on these events, gathering larger samples. Experts hope this will lead to undeniable discoveries. Spotting these rare collisions is a huge challenge due to the immense amount of data. In the LHC, 40 million proton bunches collide every second, each with at least 50 individual collisions. Detectors like ATLAS and CMS capture images of these collisions. Each picture is way larger than a regular smartphone photo. Storing just 1 second of these images would fill 1 million gigabytes. In every second of information collected is a trigger, a set of computer processors, to pick out a few hundred collisions each second that are worth keeping for scientists to study. Even with this selection, the LHC's records already, at most, they might get some interesting clues and maybe pictures of events that hint something new, sparking discussions among theorists. The next phase, predicted in models of dark matter reactions. These particles aren't made in large amounts by strong interactions, but instead by weak and electromagnetic interactions. Having more data from the collider could be really useful in discovering them. Detecting dark matter particles is tricky because they interact weakly and don't leave clear signals in the LHC detectors. Scientists look for visible particles that move in response to the invisible emissions, following the laws of motion. To catch these subtle signals better, and the increased data rate will help reveal rarer events where the moving particles are easier to see. This upgrade will significantly boost the ability of ATLAS and CMS, two LHC experiments, to spot these signals. CERN, the European Organization for Nuclear Research, is planning something big, an even more powerful particle smasher called the Future Circular Collider. This